Okay, draw a graph for each inequality. 4. Is it open or closed circle? Closed. And is my arrow going to go to the left or the right? The left, because my inequality is pointing to the left. Let me give you an example. Oh, you can't see my example. Wait, I have another example. Hold on. Okay, write the inequality for each graph. So now we're going to go backwards. So we have x, and my arrow is going this way. So it's greater than, and not equal to, because it does not have the filled in circle, and then -4. Great job. Those are middle school review, but super important. Okay. Scooching down, number 9. If you guys could please write this on the side. We're going to answer these questions and find the equation. Okay. First thing I'm going to do is find the equation. And by doing that, I'm going to find a couple points on this. So here's a point. Here's a point. Just going to put a couple dots on there. This point is -1, 10. And this point is 0, 5. Okay, so my equation is y equals, what is the y-intercept? What's A? 5. And what's the multiplier? It's not 2. 1/2. It's going down to the x. Okay, now if I said what's the divider, it would be 2. Okay, and then we're going to answer, so that part's done. And now we're going to answer these questions. The domain is the x, so is it going forever to the left? Yes. Going forever to the right? Yes. All reals. The range. So the range is going to here, but it's not going to touch the x-axis because it's exponential, but it's everything above, so y is greater than 0. And make sure that you don't have or equal to, because it's not going to touch. The asymptote is the line that it approaches but does not cross. So in this case, it's 0. You can draw in the asymptote on these with the dashed line if it helps you. Here's a pro tip. Usually the numbers in the range and the asymptote match, but this one is equals and this one is greater than most of the time. The x-intercept is none because it will not touch. X-axis is hot lava. And the y-intercept is 0, 5. I do. I did not look it up yet, though, but I'm going to have plenty of time while you're setting up your notebook. Okay, so I think we are done with the notebook. You can scooch that aside. I mean, the packet. I don't even know what I'm saying. special. It's Tuesday. I use that excuse every day though, like what day it is. Okay, so here are your instructions. I would like you to first write this down, and then I would like you to solve number 24 on your own. So this is what we've been doing the last few days with the four steps, with the number line, number, you know what to do? Okay, so first thing you're gonna do is write this stuff, and then you're gonna do number 24 on your own or with your group, either way. But just a note, you're going to get a decimal answer. That is okay. Don't be worried. It's totally fine. Yeah, then you won't be like, I did something wrong. Oh, goodness. Okay, I'm gonna give you 30 more seconds. Okay, so I'm gonna show what I have for my answer now. Let's see how you did. Okay, I got 2.5 for x. I put 2.5 on my number line with an open circle. I tested 0 and got true. So I put my arrow towards 0 because it was true at 0. And final answer, x is less than 2.5. Do you guys have any questions about that before we move on? So you have a quiz a week from today. The very first problem is one of those. There's 4 problems. 2 of them you don't know how to do yet. One of them is this, and one of them is where you find the exponential between 2 points by counting the b's and then doing the equation and taking the root. Okay. All right, now number 25. We need to start solving absolute value equations because we're going to do absolute value inequalities. And what do you guys know about absolute value? Yeah, no. So it goes positive no matter what. If it's positive, it's positive, and if it's negative, it's positive. Okay, interesting fact, because of that, absolute value equations have 2 answers. They all have 2 answers because the positive could go to a positive or the negative could go to a positive. Okay, so what you do with an absolute value equation, they're not hard. You make little arrow guys off of it, and you take the first part and equal it to positive 16. And then you take the first part and equal it to negative 16. That's because the positive can become a positive and the negative can become a positive. Notice that I left the part that was inside the absolute value the same on both. And the number, the constant outside, was the positive and the negative. Okay, and then I just solved them like regular. So plus 5, plus 5, dx equals 21. Divide by 3, x equals 7. Plus 5, plus 5. Okay, now absolute value equations, they can have a number line answer, but because it's equals, it's just the 2 dots. This is very important. There's no arrow or anything with absolute value equations because x equals those 2 numbers. So you just have the 2 dots on the number line. Okay, so I feel like this is pretty easy, not too bad. You just break it into 2 pieces. You take whatever is the number on the outside, and have one of them be positive and one of them be negative. Solve them separately, and then just put them on the number line. Notice I put them in the correct order though. I put the lower one here and the upper one here, and then put the dots on there. Yes, and then, yes, they'll always be closed dots.
Would it work if the equation, if the 3x minus 5 is 3x plus 5?
It would be 3x plus 5 equals positive 16, and 3x plus 5 equals negative 16.
Okay.
So the part inside the absolute value stays the same no matter what. So think of this like a rock. This stays the same every time. Whatever this is in there, it doesn't even matter. This could both be negatives. Doesn't matter. You just change the sign of whatever's outside. Okay. Now, are you anyone having any trust issues with what I did? If you are, it's okay. What is 3 times 7 minus 5? If I plug it back in, is the absolute value of 16 16? Yeah. Okay. So what if I did 3 times negative 11 thirds minus 5? That would be negative 16, but the absolute value of that is positive 16. So if you plug them back in, they should both work. Okay. Now this is going to take you a minute to set up. I think these two problems take longer to set up than they do to actually do. Thank you. You're the best.
Yeah.
Did they really mail this to the high school?
No.
Okay, I'm going to show you the problems in the ebook that have to do with these two number lines. 26. Henry is riding his bike in a straight road when he gets a call from his mom asking where he is. Henry says he is 7 miles from home. Draw a number line with the integers from negative 10 to 10. I was too lazy. I did negative 8 to 8. Representing the road Henry is traveling along. Place Henry's home at 0. Okay, I want you guys to take your pencil and at 0 on the number line for 26, put an H for home. Then mark the positions on the road number line where Henry could be when his mom called. Okay, so he says he's 7 miles from home. Okay, so what they're trying to get you to see is that Henry could be 7 miles this way, or he could be 7 miles this way. By the way, riding a bike 7 miles is no joke. Just saying. Okay, now it says for B, use absolute value. So we're going to take these two dots, just like this, and go backwards and write it in absolute value. Okay, and there's a formula for it. X minus the middle equals the distance. X minus the middle equals the distance. Okay, and in this particular problem, the middle is 0. So x minus 0 equals, and when it says distance, it means this distance, which is 7 on both sides. So 7. So when I read this, I read Henry is 7 miles away from 0. I just don't know on which side. That was really it for that whole number line, believe it or not. Okay, now 27. Henry continues along his route when his friend Emerson calls asking where he is. Henry says, I am 3 miles east of my house. Okay, can you guys put an H now? 3 miles east of his house. Okay, so his house was here. It's really bad because they put Henry and house at this is both start with H. Which direction is east, by the way? Yeah, this is the only thing I know. This is east. It goes west and east. This is west.
Remember that?
Uh-huh. And this is east.
I like that theme.
Me too. So now Henry's there. His house is still here if you want a little house. But Henry is now 3 miles east of his house. Emerson calls his cell phone. Okay, Emerson says, I am just 2 miles away from you. I'll see you soon. Oh gosh, not if Mrs. Talbot's riding the bicycle, but that's fine. Draw a new number line marking Henry's position and Emerson's possible positions. Okay, so Emerson says he's 2 miles away from you, so he could be here or here. Does that make sense to you guys? So Henry said he's 3 miles east from his house. And then Emerson said he's 2 miles away and he could be 2 miles on either side. We don't know which side. Okay, so now we're going to use my formula again, which is x minus the middle equals the distance. Okay, so x minus, so what's the middle in this situation? 3, beautiful. And what is the distance between the middle and both of the ends? 2. Okay, so now I'm going to make sure that I show you that I'm not making stuff up over here. For C, we're going to solve this like we did in the notes. Okay, so make 2 arrows. X minus 3 equals positive 2 is your first option. X minus 3 equals negative 2 is your second option. And what should the answers be? We already have the answers. 5 and 1, right? Those are my 2 number line spots where Emerson is. Okay, so plus 3, x is 5, plus 3, 3, x is 1. So my goal here was to show you that you can go from the equation to the points, or you could go from the points to the equation, and I'm not just making up all kinds of voodoo math over here. I know. It's not Princess and the Frog situation. Okay, now we're going to move to number 28, which I really think requires more number lines. So prepare yourself mentally. Okay, here we go. 28. Amanda messaged Henry with the following message. I am still, this is important, more than 5 miles away. Henry is not sure if Amanda knows that he is not at home. If Amanda thinks Henry is at home, draw a number line and highlight Amanda's possible positions. Then write an absolute value inequality to represent Amanda's possible positions on the number line. Okay, so pretending that Henry's at home, so we're going to put Henry here at home, pretending. She says she is more than 5 miles away. So what I'm going to do is I'm going to go open circles, and then these are the places that are more than, oh, I did it on 6. Whoopsie. These are all the places that are more than 5 miles away in this direction. And these are all the places that are more than 5 miles away in that direction. Okay, now I want you guys to think about that human number line we did last Friday. I had like only the sides come forward. So this is kind of what we're talking about here. So x minus the middle is more than some distance. So this is more than or far away. In this picture, the middle is 0, and she is more than 5 miles away. Okay, what do you think we're going to do next? Okay, now B. Maybe Amanda talked to Emerson and knew that Henry was 3 miles east of his house. Draw a number line and highlight Amanda's possible positions for this situation, then write the corresponding absolute value inequality. Okay, so 3 miles east, he would be here. And if she was more than 5 miles away from there, she would be 8 and up. 1, 2, 3, 4, 5. More than 5 miles away from there. Okay, so this would be absolute value x minus, what is the middle? 3. And then more than 5 miles away. Okay. And then for C, it says to solve it algebraically. So, you know how I said you guys have a quiz a week from today? Okay, first problem is one of those that we just did at the beginning where you have regular equation and then you have to test and make a number line. The second one is one of these where you have an absolute value with a number line. And the third one we haven't learned yet. And the fourth one is the B thing in the table. But we need to learn how to do this without a word problem. So this, no. Okay, now you're right though. Okay, so what I want to do is solve this algebraically so I get this answer. I want this to be my answer, but we're going to go through the 4 steps of solving an inequality just like we did before. So first I'm going to make my little arrows. Actually, I'm going to save those. First step, I'm going to pretend that I'm in denial. How do you pretend you're in denial? I don't think those two things can go together. I think you're either pretending or you're in denial. You can't be both. Anyway, so first thing, I pretend it's equals.
Should we do the negative one for the positive one?
Both. Both. Yes. Okay.
Have you ever asked yourself that question and they say both?
If Mr. Talbot asks me like what kinds of chips he wants, either barbecue or like regular, he's definitely gonna say both. Okay, so I wrote it with the +5 and I wrote it with the -5. Keep in mind, we actually want our final answer to be this. So I'm going back and figuring out how to solve the problem without it being a word problem. +3 +3 x equals 8 +3 +3 x equals -2. Okay, now checking back for reasonableness in my previous answer, where are my dots at 8 and -2? Yeah, okay. Step 2. This is where you're going to have a little bit more complicated number line. You're going to put your -2 and your 8 on your number line. You're going to have to decide if they're open or closed. Open. And then what you want to do is figure out an easy number between them. It doesn't have to be 0. I'm going to use 0 in this problem because 0 lives between them on the number line. But if 0 wasn't between them, I would pick something else, which is going to happen with the next problem. So just hold on. Okay, step 3, test 0. And I'm going to test 0 in the original problem, just like I was doing before. 0 minus 3 is greater than 5. Absolute value of -3 is greater than 5. Absolute value of -3 is greater than 5. False. Okay. These problems only have two options. You're either going to be true in between the points or you're going to be false in between the points. This one happens to be false in between the points. That means that it's true on the outsides and my arrows go out. And step 4, for this situation, because the arrows go out, I write two inequalities with an or in between. So this is x is less than -2 or x is greater than 8. Mhm. A lot. That's the notes for this. She's lengthy. Okay, number 29. Step 1. Pretend you have equals and solve. Okay, does anyone have any questions on step 1? I just want to make sure I go slow enough. Is step 1 okay? Okay, now step 2 is when I draw my number line. You always want to go least to greatest. So 1 is going to come before 5. Yes, what? Okay, and then for this one, it's going to be open circles. And I think what you were going to say is you can pick anything in between these two. You just did 3. 3 is fine. 3 is a great choice. Okay, so when I do step 3, I'm not going to test 0, I'm going to test 3 because 3 is in between the two. It doesn't have to be exactly in between the two. It could be anywhere in there. Like 0 was not exactly between, just anything inside. So I have absolute value 3 minus 3 is less than 2. Absolute value of 0 is less than 2. 0 is less than 2. True. So that means I'm true at 3 and I'm false outside. Okay, hold on. And instead of making arrows, I connect the two dots. Okay, excellent question. Okay, so what you put for the final answer is you put the lowest dot and the highest dot. Then you choose the letter in the problem and put that between them. And then you make arrows that always point left. Always point left. Every single problem, they're going to point left. And then you just have to decide if they're open or closed. And these are both open. So that's your final answer. So when you read this, you read X is somewhere between 1 and 5. I don't know. This one is not short. I would love it if we did. We do have 11 minutes. I might do it. There's a chance. I just don't want to go too fast because I'm afraid that there's steps. Okay, now for mental preparation. There are 4 examples, but 3 and 4 are just weird answers that don't have any work that you have to do. The only work we really have to do is on 1 and 2. But I want to make sure you guys see the weird ones. Which is really good because if we do finish, the block day is just a digital escape. So Chromebooks,
It's already turned.
Chromebook charger, yeah.
Wait.
Just put it off to the side, Dylan. Don't have it open yet. Okay, example 1. Step 1, pretend it's equals. Now it's an absolute value equation which has 2 answers. Okay, any questions about how to solve the absolute value equation part? Okay, now I'm going to put these in order. So I have -1 and 5. And I go back to the original problem. Those are both open. And I get to choose anything I want between those. And I'm going to choose 0 every time it's an option because I'm a lazy person. Plugging in 0 is easy. Any questions about how I set up my little baby number line? Okay, now I'm going to test 0 And it doesn't have to be zero. It could be whatever you chose. You can do whatever number you want between there. You could do like 0.1 if you wanted to. I don't know why you would, because that'd be hard, but if you're feeling spicy. Okay, so that means in between them is true. And it's false on the outsides. And that means I don't do arrows. I connect the dots and make it look like Baymax. And then -1 to 5. The letter in the problem is X. Open circle, open circle. I know. So I said I don't want to go too fast though, because people won't. Right. And 3 and 4 are literally like no solution type deals. Like you don't actually have to do anything. Okay.
But it's 10:27
Okay.
already.
You can finish this on Thursday.
All right,
No problem.
take it.
Yeah. Why did I make a giant? That's really weird. I don't know, because they're separate problems. Okay, so when I make the number line this time, I have to think -3 goes on this side
I don't see it. I see it.
and -1 goes on this side. And this time they're closed. I really only have one good option. -2, yeah. Great job, false. Okay, so that means it's false between them and true on the outside. And my arrows go out. And when your arrows go out, you just write them separately with an or between. What? And notice your arrows will go out in your statement, just like they go out in your picture. Okay, now if you can write example 3 and example 4 real quick. Example 3 is infinite solutions. And example 4 is no solution. That's explain for 5 seconds. You only have to worry about infinite solutions and no solutions when the number over here is 0 or negative. Because absolute values always have to be greater than or equal to zero, since they're always positive, and they're never going to be negative. So you just have to keep your eye out for if this is zero or negative, then you don't have to actually do any math, you just look and see if it works or it doesn't work. I did it. We did it. This is Stava, your teaching machine. Woo!